This is the second episode of AI for Real. My name is Alvar. I'm the host. We have here today Nelson as a co-host. This podcast or this series of interviews is brought to you by the LisbonAI conference, a conference for and by builders that are working in AI. We have 5 tracks at the conference. One of those is physical AI. That's why we have our guest today, which is Ville from Voyage Robotics, that's trying to build the tools to make robotics great again. No, not robotics great again, but something like
Safe
that.
again.
Thank you, Oliver. Robots great again.
Yeah, robots great again. That's a good slogan. Okay, maybe we can start by doing an exercise. Explain me, like I'm 5, like how do robots work? Like why do you need physical AI and what's everything? Like we see spaceships and we see autonomous vehicles. Like how do these things work?
Yeah. Well, I would say that traditional industrial robots don't actually have AI at all. Instead, we can sort of program our robots to do the same task over and over again, and we don't need any really sort of calibration or like decisions to be done on the spot. We can just say that we have a conveyor belt, let's say like this, drags objects, and we say that a specific object has to be in here, and then our robot can just come in and pick it. And we sort of enforce this object being at point A at time X through
Okay.
calibrating the whole thing like that. But it turns out not many tasks in the world are actually like this. Most tasks in the world are kind of messy. You need to adapt in real time to these. And which is why the AI models that we have deployed are typically quite sort of engineered systems where you have maybe a vision model that tells us the object it's there, and then a motion planning model that tells our robot that in order to move from A to B, we need to make these motions. And again, it works quite well in autonomous driving. We used to have systems that would detect stop signs and then a program that would tell us if stop sign in an intersection, then stop where we think the intersection begins, stop for a few seconds and then drive. But again, the stop sign might be sometimes missing or partially covered or just otherwise not clearly visible. So then a lot of companies have started to learn directly from the images and just by looking at hours and hours of data of humans driving, because humans don't do such robotic actions. We just look at what we do and then just do things. So a lot of the newer style robotics, which I'm excited about, just looks directly at images from the robot's cameras and then just controls the robot through a single network that's just learned like a human.
So that's basically like the core of what you're trying to build at Voyage Robotics. You say in your website that you're trying to build human-like robotics or robots in this case. What are human-like robots? Are they robots that look like humans, that learn like humans, that behave like humans?
I think it's more about the controls. If we look at the motion planning based robots, we see that they move like robots. We even have a dance move for the robot, which is this sort of very robotic point A to point B type of movement. I don't know how to dance. Maybe Alvaro or Nelson, one of you can demonstrate what it might look like. But some
I know
of the
I'm not
newer,
okay.
some of the newer style robots, if you see newer demos of the Tesla Optimus, for example, you can see
Yeah.
how quite precisely it can align its hand on, for example, on the recent demo on the bin and then open the lid and then sort of pick up the back by kneeling down kind of like a human and then placing that. And that's because the Optimus hasn't been programmed to do this same movement over and over again. Because we would have to program every type of bin separately, every type of bag, every other task that we would imagine. We've learned that from human demonstrations. We've had a human doing that things and now we can get a robot to do that. So from my company's side, I would say rather than making these robots ourselves, we're more focused on enabling other companies build such AI systems and more focused on the reliability of these because Optimus
Yeah.
today is still a demo. It is used, I believe, in a number of production applications, like sort of, I think Optimus, there was a video of picking and placing the battery cells. And I'm sure there's many other tasks that we outsiders don't really know about. But these robots are still mostly in labs today. And that's because the reliability of them is not at the level of actually using them in the real world where we need sort of 100% reliability, opposed to maybe language models where we can cope with sort of the robots or the chat GPTs making mistakes every now and then. With robots, we don't really want our robot dropping our dishes, for example, if it's trying to put them
Oh,
in
oh
the
no, no,
cupboards.
don't you dare, robot, because we need those dishes. It's funny because we do see like even on Tesla when they presented the Optimus, it was a little bit like some idea that were controlled with even VR, and they were even actually upgraded on the distance. But what we do see more than ever is the necessity to actually do mundane tasks, just like as you said, like cleaning the dishes or unloading the dishwasher and just picking up the plates and putting it there. So having the ability to actually control and be able to have that human-like ability to actually do those types of tasks, I feel like it's quite fascinating. I'm going to jump in first,
Yeah.
and this is the most important thing. This is a full disclaimer. I'm not a professional here. Alvaro is, so I don't know how to actually properly do this, but I'm very curious. So what actually fascinated you into robotics? What was the first thing? What was the first robot that you actually saw?
I wish I had a childhood story about this,
Oh,
but I had
make
a
one. Yeah, it's fine. You can make one.
I had actually more, I don't know, weird path because I
Hmm.
studied computer science, but I never intended on getting into robotics. I sort of did. I was supposed to start in travel tech during COVID, but then COVID happened and I actually was laid off from my first job before even starting it. That must be some sort of a, speed run or record of like 80% getting
It
laid off
is.
from a job before you even start it. So I ended up going into the finance, which a lot of people in the UK do. We have sort of the financial industry that sucks up talent really from everywhere else. Uh, but then I didn't see myself doing that for the rest of my life. I wanted to do something
Hmm.
much more tangible. And seeing the impact that ChatGPT had in around 2023 or 2022, I think, and sort of seeing that if we take this technology and put it in a robot body, how we could be able to automate all kinds of boring jobs, like for example, doing the dishes, doing the laundry. I just
Yes.
have a laundry, load in the machine right now. I need to be doing it after this podcast. I wouldn't want to do that. I would want robots to do that. And then maybe the more interesting jobs that, let's say, writing code, doing art, doing podcasts can still be done by humans in the future.
Oh, please, let's hope so, because Alvaro will be out of the job. So, no, but kidding. It's this is the best part of like for me having this entrepreneurial kind of path and seeing the passion of developing a mission is really driven by necessity. You know, just unloading the dishes or whatever it is. It's like if you have the ability to build something and you have the know how to do it. So that is the drive. So I really like that. So even if you don't have a really novel backstory, it doesn't matter. It matter is actually you're building, and that's the most important thing. Alvaro, I'll pass it on to you because you know what you
Yeah,
do.
yeah, yeah. You mentioned like the ChatGPT moment, which
Yeah.
was like not the moment where transformers were created, but probably the moment where AI and the transformer architecture went mainstream. Um, how close are we to a ChatGPT moment for robotics, like super democratic access to let's say B2C or something, consumer robotics?
Well, getting started with robotics as a developer is easier
Hmm.
now than it's ever been. I did some sort of back of the envelope calculation. When I started, the cost of a robot would be more like a sort of car level. Today it's the cost of an Android phone maybe, with some of the sort of lower cost robots like the SO100 from Le Robot team in Hugging Face. But this is still a developer tool. It's not something that you can buy and expect it to do all kinds of chores. It
Hmm.
doesn't move, for example. It's not human sized. I think we're still some way off from having the technology. And then when we do have the technology, we're a little bit further ahead in terms of like diffusing it into actual workplaces and diffusing it in people's houses. I believe for the car, it took like over 50 years for there to be a billion cars in the world from sort of the first auto developed, I believe, in Germany, maybe.
But do you think, like, from a technical point of view, do you think we already have the technology, like the model architectures, the data, everything, or are we missing something? And what's the bottleneck here? Like, what should we solve as soon as possible to get to the point of the ChatGPT moment for robotics?
Well, we might have the models or the sort of the architectures. If we
Mhm.
do, we don't actually know because we don't have the same scale of data to try them. I don't think we've really reached the end of what we could do with the models that we have because the language models that we see have been trained on basically all of human knowledge or most of human
Mhm.
knowledge. We've given them all the books to read. I think Anthropic bought libraries worth of books, sort of scanned them page by page
Yeah.
into their model. And of course, all of the internet, Wikipedia, and so on, which is hundreds, if not thousands of years of human effort. We don't have the same scale of dataset for robotics. If we did, we might already be at the ChatGPT moment, but it might as well be that maybe we are missing something. And maybe, in fact, there are other ways to learn. Traditionally, robots have been trained on simulations, for example.
Mhm.
We know that when we see robots doing the humanoid robots walking or sometimes doing backflips or other things, those movements are actually trained in simulations. We don't need to have humans backflipping in order to train a robot to backflip. We can test that in simulation. But other scenarios are much harder to simulate. Maybe simulation is the answer, or maybe learning from humans. Maybe we don't need data of robots doing things and humans
Mhm.
controlling robots, which is very expensive because you need to have the robot. You would need to have Tesla Optimus in your house to train an Optimus to do things today. Maybe we can
Okay.
learn from humans because Optimus looks like a human. So
How
maybe
how
we
Yeah.
can
how can
take
we do this?
um, if we take a look at the human hand, for example, we might have technology that sort of, we kind of already have it that looks at each of the joints in here. And then
Mhm.
if we do that, we can sort of track the movement of the fingers and then imagine that's the movement of the robot. We even have technology that can in-paint the human hand to look like robot hand. Robot hands tend to look a bit different to human hands, for example. So if we have cameras, it would look different from the perspective of the robot AI. But of course, the hand can be occluded, like parts of my thumb are not visible
Mhm.
right now, and so on. So it's not quite perfect. We also don't get the sort of the hand moves differently than a robot hand. Robot hands are still a bit robotic. So the commands to tell our hand to move and tell a robot hand to move aren't exactly perfect.
Okay, so it would be like applying the same approach that we apply to self-driving cars, but to robot movements, like giving a lot of human behavior videos and trying to map it to a robot equivalent, like a hand or a leg or something, and making the model learn those behaviors instead of like video to behavior instead of programming that exact movement to be something like this, right?
Yeah, overall. And if we want to get a robot assistant in a home, there are just so many kinds of objects in homes to interact with. Objects, kitchen counters look different in different places, fridges. Sometimes if you go
Mm-hmm.
to a neighbor's house, you might struggle to operate the shower, for example, because they all look very different if you've had that moment, or a hotel. So having robots sort of collect all that data from all the different kinds of houses, that's going to be a big challenge.
Uh, Nelson, I don't think we are can listen to you.
Yeah, I think you
Okay, but
muted.
I have another question. When Nelson solves this, you mentioned the Le Robot Hugging Face project.
Yeah.
Uh, what is that,
Mhm.
and why is it important, or why does
Mm.
it matter?
I think it was around May to June last year that Hugging Face announced this project and their sort of first entry into robotics. And their goal was well, I believe their goal was to make robotics more accessible to people. And as part of this project, they've implemented both sort of software and hardware to
Mm-hmm.
make it easy to get started with robots. On the hardware side,
Okay.
they have low-cost robots, like I said, that you can spend a couple $100 or euros, I think more in dollars because of the Trump tariffs that have been in place today uh, to buy one of these arms. And then on the softwares,
Whoops,
we have,
having some feedback here.
yeah, on the software side, there's code that allows you to easily connect to one of these robots, easily record your own data sets, easily start training models and run the models on the robots. And
And
yeah, I think there's been some impressive projects that have come out of this, especially from the community. Like recently, there was a large worldwide hackathon that was hosted in, I believe, tens, if not hundreds of cities all around the world.
okay,
And it's really been
what
awesome to see the community around it develop.
what are your contributions for this
Yeah, I
project?
started working with the team sort of as a community member. I think it was around August last year, so almost a year ago. Just initially sort of connecting the robot that I use actually with the library, which ended up never being merged, but it's been out there as a PR since then.
Mm-hmm.
Um, I think I've helped lots of people, so I've answered questions and so on. And then more recently, I helped the Hugging Face team sort of on the data curation side for their foundation model. As we know,
Okay.
foundation models in language space are sort of ChatGPT and so on that are aiming to do many types of tasks. In robotic space, we could also have a foundation model, although we are still quite early in that stage. And Hugging
Mm-hmm.
Face aimed to build a data that's been trained on data that people in the open source community have collected from all over the world, rather than being collected by one large company and their employees. And of course, collating all this data, connecting it all in the model sort of training pipelines is a challenge. So I was helping them out. I was very glad actually to be able to help them with some of
Okay.
this work.
I want to explore a bit that open source side of you. Do you have
Yeah.
Nelson back?
Can you hear me?
Yes, we have
Yes.
Nelson
Yay!
back. Nelson, you
So
were saying something.
I was saying so many things, and none of them really interesting. But I'll go back to them. So just a couple of things. So first thing, I really like your approach, Phil, in terms of like you tackle something that is really about getting proper data and tapping even on the ChatGPT moment that you can actually access large data sets and you can actually train on it. What you do see now is like NVIDIA trying to actually get a lot of different types of simulations. And yes, people can do backflips and also do robots, but you actually need to have a little bit more accessibility in the house and actually doing that through either open source or with your contributions, and also to actually be able to get people trying different types of utensils at home or in trying to mimic a little bit that experience. My take is a little bit more mundane, but how do you feel like people can actually have robots in house, and what are the easiest path or less resistant path to actually get some of those robots in house? Do you feel like people get them because people have Roombas? What's what's next? Where do you think people can actually have some benefits from it?
Um, I think the models we have today, if we can get the right data, could already automate some tasks. I think cost is a challenge, but if we can get, relatively a cheap robot, but I think the big problem is that consistency we talked
Mm,
about. Like you could probably train a robot today that is able to pick dishes pretty reliably from a dishwasher, but every now and then the robot's just gonna drop one, and it's hard to stop it from doing that. Actually, I think it's a bigger challenge today to get something to be 100% reliable than it is to get a robot that can do a thousand different things at sort of 60, 70, 80, even 90% reliability. But in homes, we really need that 100% reliability. Otherwise, people are going to blame the robot from, destroying one of their grandma's favorite heritage dishes.
if it is true, it is true. It's like it is.
Yeah, and actually that is something that I'm looking to address, making
Mm,
sort of getting robots to be reliable. And I actually think there's chance for us humans to be a part of that. I think robots struggle in the edge cases, but humans are very good at that. That's what we are
yeah.
exceptional at. Even in the AI agent space, agents always sometimes get lost. They might get stuck. They might make mistakes, hallucinate things. Humans are much better at saying, I don't know, or can you help me? asking for help. I think what we need to do is get the robots to be able to ask for help, detect any issues in them, and then just have a human helper help the robot. And maybe we can't get the robot itself to be sort of above 99% reliability, and maybe we can bridge use human intelligence there on those edge cases. And maybe that's what's missing, rather than sort of larger and larger models or, more capable hardware.
So breaking it down into smaller chunks and then addressing different types of small issues, and then from there build up. One of the things I feel like it's really important, maybe it's just me because I'm getting a little bit more senior, but I feel like elderly care could be something very easy to achieve. Just having the ability to, assist somebody in need, having the ability to call human, there's always something there that you can actually address. So, having a little bit more of that training could be something way more on the easy entry level to actually get more of this tasks being more repetitive. And from there, if they need to trigger something to have human interaction, they can do it.
Yeah, and we could allow people to stay at their own home longer, rather than having to go live in an assisted living facility. If we have a robot helper sort of helping out with maybe some of those cleaning tasks or other tasks that would otherwise become easily impossible at some point, which would actually be a really, really good thing to be able to say in the future. One of the dreams sort of mine would be to help people, disadvantaged people, as well as to maybe have robots exploring the space that have my code or my AI models on them.
Oh, that's a pretty cool dream, by the way. I like that.
Yeah.
Okay, so let's jump to Voyage Robotics again. So you're building this company that's trying to help companies that build robots do it better, right?
Yeah.
How are you doing that at Voyage Robotics, and why are you doing that in an open source way?
Well, I think there's already quite many companies who are addressing sort of the data problem, who are trying to build datasets, which I think is a large problem. And I also think there's a number of companies that are already sort of beginning to train the models themselves. But I think the idea of trying to understand the AI models better themselves is quite underexplored, as is the sort of idea of how do we optimize the reliability in here as well. It's maybe something that in academic research, for example, you often get a lot of points, I would say, or attention from a new approach or better success rates. But a lot of the problems, I would say, are engineering problems once you reach sort of 99% or something. So it's maybe something that some of the more sort of academic research doesn't necessarily attempt to address the same way. And in terms of the open source stuff, I think firstly, everyone understanding robots better is super important. I think we won't accept robots into our homes or robots that care for our elderly if we don't know what they are doing, if we can't prove that this robot isn't going to do anything like seriously injure, for example, one of these people. Or if an accident happens, we need to be able to explain why it happened and why it will never happen again. And one of the keys, I think, sort of is to look inside the robot brain, which is what I've done through the sort of mechanistic interpretability and attention mapping work that I've open sourced. And I would really love to see sort of more companies explore the interpretability side of AI robots, kind of like how Anthropic has explored the interpretability side of language models, and trying to identify what are the risks, what are the cases when the models are doing something wrong, can we detect these, can we try and prevent these. I think it's going to be especially important in robotics because the damage that can be caused is much larger and much more tangible than the damage that a language model might be able to cause.
It's super interesting. You mentioned interpretability and attention, because that's what changed the game for large language models, right? When you could like map the attention of the model inside of the sentences and the texts. Is it similar in robotics, so you can understand what's being like weighted the most?
Yes, what you're referring to is the attention mechanism, indeed, that we can sort of look at each token and what other token in the input it most clearly attends to. I'm
Yeah,
I'm
yeah,
not
yeah.
like a professional researcher, so I don't
Yeah,
know
yeah,
how
but
to explain this.
is it
Well,
similar in
well,
robotics?
when I say, yes, it is similar indeed. When I say attention mapping, I actually refer to sort of visualizing this attention. So what we can do
Okay.
is we can look at these patterns inside the brain of the robot, inside that transformer model, and we can actually map them back into the images of the cameras. So we
Like
might be
following
able to
the gaze of the robot, let's
Yes,
say, something
exactly. We
like that.
might be able
Okay.
to say that in this case, our robot failed because it didn't notice that object, for example, right there. And we
Mm-hmm.
can might be able to tell that because the attention pattern reveals that. But these models are black boxes. We don't necessarily know if it didn't pay attention to that because
Mm-hmm.
of the mapping or because it had decided to use those features for some representing some other features. So it's not a perfect solution, but it can tell us a
Okay.
little bit at least about the models.
It
It,
does give me. Sorry, I'm jumping in. Just two things. First,
go ahead.
it gives me like a sense of like Westworld. I don't know if you've seen it, but it's like go into inside the brain actually. But it's pretty much like just debugging by logging, and, and you just have access to what happened and actually go into that. So it is so vital to actually have ability to perceive what they actually didn't, or
Yes,
the situation they face, and how to actually work towards that. Yeah.
because in
Mm-hmm.
AI context, we don't have the same kind of logging. We
Mm.
don't, if something goes wrong, we
Yeah.
don't necessarily have a stack trace of like exactly which line of code was there was a bug in there because
Mm.
it could have been just the AI model had learned a wrong representation or missed
Mm-hmm.
something, and it's very hard to tell why that happened. And if we don't know how to tell that, how does a politician who asks us, how do we make sure that this robot is safe? It's not going to harm anyone. What are we going to answer to that person? I don't know. Like, that's why we need to know exactly that this is the reason. And here we can prove to you, because we can understand this model, this feature, we can prove to you that this isn't going to
Yeah.
happen again.
Oh, this is nice.
I want to talk a bit about business, maybe
Yeah.
last topic before the end of this conversation.
Yeah.
Like open source has this risk of you basically are exposing your source code, right? And you
Yes.
have all of these companies like Tesla, Figure, even Google and Meta are investing in robotics right now. How do you like what's the strategy to fight them, because they have infinite resources and they don't really want to share their source code, so
I think there's a few things. The first thing is that you shouldn't underestimate the open source community. Last time I
okay.
checked, and this was
Yes.
maybe a month ago, the LeRobot Discord, for example, had around 10,000 members, and I
Wow.
believe that's more than, for example, the employees at DeepMind. So if you counted each member of the open source community as an employee, the open source community would actually be the largest research lab in the world, larger than DeepMind, larger than OpenAI, and so on. So if we all work together, we can actually, help each other and really sort of build on top of each other. And I see that open source models will be to some degree competitors to some of the closed source models. And
Hmm.
in a world where closed source models are the only ones that exist, I think that all the robots around us will be controlled by a very small number of companies. And I think it would be much safer and better for the economy, better for people, better for everyone if anyone could start building one of these robots. And we need open source for this. But I do agree that you can't open source everything. Every company needs to have some own competitive advantage. So I think for me, the question is that today we're quite early. Today, I think the bigger risk is being too closed because the real value of the business is coming later. But I think in
Hmm.
the future, you do have to decide some aspects of that stack is secret to you. Maybe it's some of the data sets you have. No one else has access to
Okay.
the data, so you're able to sort of build on top of that. Maybe it's some understanding some processes, some models in there that maybe you have a simpler version available open source, but then a much larger and more complex version in closed source that you would have to pay for. So people will still be able to build on top of sort of what you've done. But if
Hmm.
they want to use it in a more serious project, then they would sort of join you on the commercial side.
Okay, so we are super early, but let's talk about the future, and this will be
Yeah.
the last question. So if Voyage Robotics succeeds, what does the world will look like in 5 years?
I want to say that we helped AI robots and service robots get into the world before they were ready. And we did it by leveraging humans because we know humans are intelligent. And rather than getting to AGI or having to wait until AGI for a robot to do your dishes, maybe we can have a more pragmatic approach where we have a model. It's maybe not quite ready today, but we need the robot today. So we deploy it there. We have a human assisting the robot, human assisting it when it needs help. And, the technology we built to sort of detect these errors was the deciding point there that allowed us to do this.
Okay.
Just a quick thing. Do we need to stop?
I guess, I don't know.
Okay, just one thing.
You can go.
One more.
Yeah.
I just one
One
thing.
more
One more question. Have you ever been to Lisbon?
No.
Yes.
First time.
Okay,
I've
cool.
been to Madeira.
Doesn't count. All due respect, love from Madeira, but it's so exciting.
Beautiful
Actually,
island.
having a techno optimist actually building and caring about open source and building and having the first thing that get pushing into my mind is quality control. You're always talking like a really high quality rate, having something testable, having something for humans to use. So having this type of approach is something that builds me and it gives me a lot of pride to actually host you in Lisbon and have you in LXAI. So yeah, I just want to say
Thank you, Nelson.
thank you.
Thank you so much. Yeah, it's
Okay,
exciting.
I would have said it better. So I think we can end this right now. Thank you, Ville, again. It was super interesting. I think what you're doing is amazing. It's like most of the questions were pure curiosity from my side.
Thank you,
so
Alva.
congratulations on that. And I just want to remember the folks that are seeing this that the tickets for the Lisbon AI conference will be live in a few days. Go to lisbonai.xyz and don't miss this opportunity to meet with Ville and everyone that are building physical AI and other stuff with AI at the conference in Lisbon in November. So see you there.
Yeah, LisbonAI.xyz.
Exactly.
Hey, Phil, thank you so much. Bye bye.
Bye.
Thank you. Bye.